Right, now we're on to looking at bases, and so we've looked previously at the characteristics of acids. Now let's focus our attention on bases, and we're looking at the properties of bases and examples of bases before we get into naming them. Okay, so let's have a look at here. So what about taste? Well, acids taste sour, bases are bitter, and so not that you of course ever taste bases, but bitterness is usually the characteristic of a base. We have different types of bases. We have inorganic bases, so sodium hydroxide, magnesium hydroxide, lithium hydroxide, etc. And then of course we have organic bases and amines. The simplest amine of course is ammonia. That one's quite common, ammonia. There are other amines which we will look at in this module and of course in other modules as well. So please highlight this characteristic of amines and get that in your head, because when we start looking at more complicated examples of amines, it'll then make sense. We have another example of an amine here. So the simplest one is ammonia, and then we have methylamine. And so we're going to look at that structure there. Then we have many uses. So here are some bases in terms of cleaning. We have here some powder that is used to wash clothes. We have some caustic soda which is used to clean drains. So bases are usually associated with cleaning. Okay, they're very caustic. What about pH? Well, pH is where we have an alkaline solution. So when a base is mixed with water, it makes an alkaline environment, and that gives us a pH that is greater than 7. And so we can see here some common examples here: seawater, baking soda, and notice we've got ammonia, soapy water, bleach, drain cleaner. So that is greater than 7. Bases produce mostly OH ion or OH minus ions, so that is a hydroxyl hydroxide ion, when they're put into water. Now they're known as proton acceptors, and we're going to look at that in more detail later on, but I'm just getting some of the terminology into you. So acids were proton donors and bases are proton acceptors, so just getting those terms in there, and they produce OH minus. So if I have an OH minus, for example here, let's say I had an OH minus from sodium hydroxide, then it's a proton acceptor, because if that OH minus comes across a H plus in solution, then it'll accept that H plus, and then that'll make water. So here is the base and this is the acid. Okay, and so that is one definition which we'll come across again later. Now we can distinguish between these pH by using universal indicator paper or solution, and you can see here I've got an example of that where we're testing different solutions, their pH values, and so we've got different results there to indicate that we have different pH values. We've got some bicarb soda which is giving us a pH of around about 8. Then of course we have some cleaning solution here, but this one interestingly is an acidic environment, and this one here is slightly acidic with some demineralized water. Very interesting there, but we can see we've got a base there, so we can distinguish between the pH of different solutions and classify them as acid, base or neutral. Here's some typical examples of bases where we can test with both indicator paper and solution, and so here I've got my red, I've got my blue, and I've got indicator solution there as well, universal indicator. And so we can test a variety of acids and bases, but in this case we're testing bases. We've got some sodium hydroxide, ammonia, and we've got some calcium hydroxide, etc., all looking at bases and seeing what pH they are. And as you can see, the red litmus now turns blue in terms of litmus paper. Remember that acids had the opposite. Well, red litmus turns blue. And then we have our universal indicator colors as well. Sometimes people remember blue is base, right? So blue equals base. And so that just means that the blue color that you see means it's a base. So if you have a blue strip of litmus paper, it stays blue in base. If you have a red strip of litmus paper, it turns blue in base. So blue is base. Okay, that's how you can sort of remember. Then of course the reverse must be true for acids. If you have a red litmus paper and put that into an acid, it stays red, and then if you get a blue piece of litmus paper and put it in acid, it goes red. Okay, so that's just indicators. Another indicator that of course we can use of the universal indicator when we do neutralization reactions, and so we can see that if we have some HCl, we use the indicator here, it's turning red, it's blue for base, but then we mix those two together, we get green. So this is a reaction of acid and bases, one of the reactions, and this is a neutralization reaction, and we're going to look at that in more detail in later videos. Okay, so there's a characteristic of base reactions there. We've already talked about types of bases here. We know that we have our inorganic and our organic, and we have different examples. So here's our sodium hydroxide as an example of our inorganic base there. Here is some ammonia, an ammonia molecule, our simple amine. Now remember, this represents lone pair of electrons. So this model here represents lone pair of electrons for ammonia, and they can bond or accept protons. And so, for example, I'll give you this one example right now. If we have ammonia, like so, and these are the hydrogens, along comes a H plus that goes down there, and then these electrons go onto the hydrogen and form a coordinate covalent bond, and then we end up with this substance here, which is ammonium. Okay, and so we have the ammonia acting as a base. It's accepting electrons, the protons donating those electrons, and we end up forming ammonium. And so that's an acid-base reaction there, and we'll look at that later on. Here is, of course, an example of an amine, and here we have methylamine. We can see that we have the methyl group, and then we have the amine portion, which we'll learn is called a functional group. And that is specifically looking at an amino group there, and that does the same thing. Just like this one here can accept H plus, so can this group, and a H plus will come along there, and that will accept it as well. So some new information that what we've had before. We're going to come back and revisit this information, but write it down now. It just gets your brain cells ready, and it's nice to do some frequent revision when we go to tend to do that, and it makes more sense. Okay. Alright, so that's it for this video. We've looked at the characteristics of bases. We've added some new information in there, so make sure you got that highlighted down in your notes and added it to your mind map, because when we do it later on and we look at these compounds, it's going to make a lot more sense. And so when we get to in other modules, when we start looking and learning more about amines, etc., because we touched on it in this module here and we've made sense of the information, it's going to make learning that material easier. It's going to make some inter-module connections as well as what we want. We want to have your understanding, and we want your thinking to be not just, I need to memorize this bit, I need to memorize that bit. We need to see that all these bits make sense in the universe and the world of chemistry, and you can move backwards and forwards between them. That is when you're ready for really hard problem solving band 6 questions, because you're thinking conceptually about acids and bases and how they work, not just, oh, this is module 6, that's module 7, etc. So we're going to try and make you move into that conceptual understanding, and mind maps and seeing those connections is step 1 of that process. So hopefully that made sense to you, the characteristics of bases. I'll see you in the next video where we start looking at the nomenclature. See you then.